All right, problem number 10. We have a lot of data here and a lot of parts to solve. Let's just go ahead and take a look. So a car is traveling at this speed, u. The driver sees an emergency ahead and 0.5 seconds later slams on the brake. And then this is the deceleration, which we'll just leave as A. And we want to know the distance the car travels before it stops. So let's be clear, this is actually a two-part question. So what's going to happen is the car is going to travel for 0.5 seconds at this consistent speed of 40, and then it comes to a stop here. And we don't know the time. We know the acceleration is 4 meters per second squared. We don't know the distance or anything like that. So we're going to split this into two parts. So for A, we have two parts. There is the constant u part, and that's going to be S is ut, which is going to be 0.5 times 40, which gives us 20 meters. And then the last part of it, we're going to slow down. So S is going to equal 1/2 times -4 times the unknown time squared plus 40 times t. So we can't use that equation either. So, well, we wrote that equation down and we can't use it, so useless. Let's try another. So moving on, let's see if this equation works. V squared is u squared plus 2as. So we stop from a speed of 40 plus 2 times -4 times s, and we're getting 1600 plus -8s. When we isolate s ends up being 200 meters. So the total we travel is 220 meters. That's for part A. Now for B, the stopping distance, if we could have no reaction time, would simply be the 200 meters. Okay, see the slow down part. All right, and for C, the difference is 20 meters. All right, now for part D. For part D, let's just be clear. The difference between, so to get C, we subtracted part A from part B. So we only consider the constant velocity part. So we have 30 meters per second versus 40 meters per second over the same time. So that tells us this is a bigger difference. Since the time is the same and we have different speeds, that gives us a difference in the distance, which is simply the rate times the time. So that's how that works. That's problem number 10.